Hello everyone and welcome back to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about stepper motor. Well, a stepper motor is a special purpose computer motor that is used to run at specific degrees as well as for 360-degree motion. This is the most common motor which are used in CNC and are used in 3D printers and two-dimensional plotters. These are generally heavy industrial motors that can run heavy load as well as they can rotate in specified, you can set 2 rotations or say 720 degree. It can also move to micro stepping so that it can move to 1 by 10th or 1 by 200th in many special motors of a degree. You can say that a stepper motor generally can rotate only about 200 steps out of 360. It makes one step about 1.8 degree. But if you use the micro stepping method to control the servo motor, it can move about 1 by 200th part of a degree, which can give a very bright clarification of the servo motor and can give very accurate results. Okay, about the stepper motor. About the stepper motor. The stepper motor comes out the stepper motor comes in two variants. They are the unipolar motor such as this, and they are the bipolar motor such as this. There are only the difference of wiring. And you can say that a bipolar motor like this has 4 wires while a unipolar motor has 5 wires. These are the difference in polarities of the coil that are inserted in the servo motor for direction and motion. There are also hybrid motors that have 6 wires. They can run both as a unipolar as well as bipolar. Okay, let's just see a diagram so that we can get a clear understanding of what is a stepper motor. First of all, let's just get it from starting. Here you can see that the red part is in a magnet. In the 1, 2, 3 and the 4 there are numbers. They are the coils that activates by getting the value from the computer and get amplified by the driver so that they can create a motion to the magnetic drive, or you can see that the axle of the stepper motor is made up of magnet for giving it motion. Okay, this is the method for controlling a stepper motor. You can see that here in the diagram, whenever the pulsating clocks in a whenever the array is called in a incrementing direction from 1, 2, 3, 4, it gives a small value of motion to the rotor, and if it goes continuously like this and continuously motion, it can give continuous motion but very precise value. If we use micro stopping, the value can be precise even more. Okay, servo motor and stepper motor. There are also special type of stepper motor known as BLDC. As we have discussed earlier, there is same principle of working in BLDC motor. The main difference is the outer coil are replaced by permanent magnets while the inner core is made up of pulsating magnetic coils, and they are controlled by high speed ESC, or you can say electronic speed controller, by microcontrollers, and they are of basically 32-bit to give high performance and high speed of values so that they are used in quadcopters. Okay, about the wiring, let me give you an example of a stepper motor both as unipolar like this and bipolar like this. You can see that this motor is bipolar because it has basically 4 wirings. That all goes to the driver. Here they are using a simple chip for the driver or you can say signal amplification. The amplification power is getting by a 9-volt battery, and the signal for running a motor is getting by Arduino. Okay, while this function is very much similar to that is used in unipolar motor, it has a driver, and you can see that there are 5 wires coming out of the unipolar motor and the power source. Here the power source is used by the Arduino, but for better performance the power source should be kept independent when protecting the motor from frying. Okay, you can see that there is the basic difference between the running of motor bipolar and unipolar is that they both run on different types of codes. Their coding is absolutely different and they have a very similar motion. They can be used both for micro stepping, but their source code and their way of algorithm and programming is very different from each other. We are talking about bipolar motor. Mostly we are talking about the bipolar motors because bipolar motor are the most common type of motor we are getting in interfacing and getting an interface and to get an operation done. In the further future chapter, we will be talking about wiring a stepper motor to Arduino and using with a driver to getting the signal amplified and running the stepper motor in the future chapters. Okay, the stepper motor library is already pre-installed in Arduino. The Arduino has built-in libraries for motion of servo motor as well as for stepper. Let's just see them. Here, going in menu, file, example, you can see when you go down, you can see the library designed for stepper. Well, here you can see that motor knob, one revolution, one step at a time, and speed control. Let's just see them. First of all, motor knob. Motor knob is a library that is used for running the motor, or you can say that it just defines the pin number in which the Arduino can be connected. Let's say 8, 9, 10, 11. And the variable there is steps. The steps is the variable which store the number of steps that has to be taken by the servo motor to reach a specified value. Here it is taking 200 steps. It means that the motor will rotate from 0 to 180 degree. You can manually change the steps as 50, 60 or whatever you wish. Now let's just see another program. Go to example and again go to stepper. You can say one revolution. One revolution is a small program which just says that the pin number motor, the motor which is connected at the pin number 8, 9, 10, 11 will have to rotate all the 200 steps to get back, to give a complete revolution motion and come back to its original position where it has been started. The motion can be tamed or can be controlled by controlling the speed. In this part we can see that the motion is having each step time difference has 500 millisecond or half second. You can also write them as 50 milliseconds so that the motor will run about 10 times faster than it. But you have to change the time direction of the both. You have to change the time value of both the variables so that it can give a clear rotation. If you change the value for 1, it means that the motor will have 200 revolution in 1 second, and after getting that it will rotate 10 times faster to get back to initial position. So it is better to change the value of both the places so that you can have a smooth motion in both the direction. Let's just see it. The another part is motor one step at a time. This is a program that is mostly used for checking the step, and it is also used for getting the precise value of the stepper motor. This program is used for getting the stepper precise value such that you can get the interval of by the interval of one step. You can see that absolutely how much angle that the stepper motor has made from the previous to the present location. Actually it is 1.8 degree, but sometimes it can also change because of micro stepping. You can change 1.8 degree to 200 times clearer, or you can say you can divide it into 200 parts to get a better clarified value. Well, this method is used for controlling of the stepper motors that are used in 3D printers or CNC plotters because they require a high level of accuracy, and for high level of accuracy the step degree should be very precise, so they are using micro stepping. We will be talking about micro stepping afterward, but let me give you a small glimpse about that. Stepping can be done in 3 parts. Let me show you. Let me show you the difference. Okay, you can say that it is same as pulse width modulation. If the pulse is long, then it can give a degree, but if the pulse is very slow, or you can say that the duty cycle is very small, then it will give the value to move motor not 1 degree, it will not give the motor to move 1.8 degree, but it can also control to move motor to half of 1.8 degree, to 1/4 of 1.8 degree, and even the 200th part of 1.8 degree. For that process the micro stepping is used. I will be showing you diagram. Wait for a second. Here you can see that the example of micro stepping. This is a complete duty cycle that has been divided into 4 basic steps. You can say that each have a difference of 25% of duty cycle, but these steps can further be broken into small parts. Here you can say that this is the method. Here you can see that each part is broken into about 7 segments so that it can give a value of 1/4 into 7, that will be given about 28. 1/28 the value of the stepping that should be done, so it can give a very precise step to be taken. The whole cycle is for 1.8 degree. At present it is able to give 1.8/28%. At present it is able to give 1.8 divided by 28, and that is the angle. The micro stepping is the most precise step that is the angle the most precise step can be taken by the help of a specified driver. But remember one thing, for micro stepping it is always used a 32-bit board as well as a 32-bit stepper driver to giving very fine values in industrial strength and in industrial hardware, all the stepper motors are being controlled by 32-bit ARM architecture microcontroller and 32-bit stepper driver, so that they can give a very fine precise value and they can run the operation at very high speeds. Okay, this was the theory about the stepper motor. Here you can see the Arduino, the wiring, the driver, the external source of battery, and the stepper motor. Here we have talked about the program, and in future chapter we will be running a stepper motor for the practical purposes. If you have any question, please ask me, or else thanks for watching.